Hello everyone. In this video, I will go over my solution for the problem named Li Huan chess, taken from today's Codeforces round. This is an excellent problem which will teach you how to interactively find the location of a king on a chessboard using at most 3 queries. So in this problem, we are basically given two people playing a game on an n by m chessboard. We are given that the location of a piece on the chessboard is defined by its coordinates r and c, where r is the row number and c is the column number. We want to find this value of r and c for the king of the chessboard, and we can ask at most 3 queries. So the player can ask the second player, what is the distance the king takes to go from its position to another position. So it can choose a cell and ask the player the minimum steps needed to move the king to the chosen cell from its current location. Note that the king doesn't actually move, which means that each question is independent, so you can ask the 3 questions in any order. But what matters is that you can use those questions to determine the location of the king. So that's what we are trying to do for t independent test cases. Each test case just contains n and m, and obviously we'll ask 3 questions and we'll print the answer based on the outputs for these 3 questions. Note that since we are just asking 3 questions, it's essentially a case bash because you need to think a little bit about all possible locations of the king, and you want to also consider a mathematical function, which will tell you how many steps the king takes to move from one cell to another cell. So you can use the math function and you can use 3 queries and look at the various cases for the 3 queries to determine what the location of the king will be based on the answers for each of the queries. So that's exactly what I'll be doing. That's how I'll be approaching this interactive problem. So let's start off by finding the distance between 2 points. So let's say that you want to find the distance between x1, y1 and x2, y2, or you can name them r1, c1 and r2, c2. So the key idea is that the distance between r1, c1, the cell at r1, c1 and the cell at r2, c2 is the maximum of the difference in the rows and the difference in the columns. Now, the reason why this is true is because if you consider how a king moves on a chessboard, you could look at the sample chessboard drawn above. You can consider 2 random cells on the chessboard, and you can try to find out how many moves the king takes to go from one position to another position, and you'll realize that the king can take this path, or the king can take this path, in which it moves right, and then down and right. So in general, if you consider two random points, the king will always have to move right, at least right these many number of times. I mean, at least down/up these many number of times, and at least right/left these many number of times. So this is the minimum number of moves it needs to go, and there's an optimal method. There's always going to be an optimal method in which you use the diagonal to minimize the number of times you go to the right or you go up or down. And to understand this better, you should draw out a few boards and a few pairs of points, and you'll notice that by using the diagonals, by moving the king along the diagonals, you can always minimize how much you can always increase the value of the row and the value of the column at the same time. So by moving the king along diagonals, we are minimizing the number of moves. We are minimizing the number of moves the king takes, and we know that the minimum value of the number of moves will be at least as much as the difference in the rows and the difference in the columns. So we know that if you move from here to here, you will need to go right at least 1, 2, 3, 4 times. You'll need to go at least 4 times to the right, and up at least twice. And the optimal method is to go up and right twice and then to go right twice. So in general, the maximum of the difference in rows slash columns will give you that equals the minimum number of moves for the king to go from one cell to the other cell. And this is the key mathematical observation required for solving this problem. So let's start off by first asking the query for the point 1 comma 1, because that's a natural starting point. And if you query 1 comma 1, or if you call the query method 1 comma 1 and you output you print question mark 1 comma 1 to the output, you will get back some distance d. Now we know that the distance d is the maximum of the absolute value of r minus 1 comma c minus 1 if r comma c is the location of the king. And you know that there are going to be two cases. So case 1, if r is less than c, and case 2 is when r is greater than or equal to c. So when r is less than c, we know that the distance is going to be r is going to be c minus 1, which means that c you can uniquely determine c, and in this case the distance is r minus 1, in which case you can uniquely determine r. Now all that remains is to find out whether r is less than c or r is greater than or equal to c, and we need to essentially try to use the second and third queries to figure out which of the two cases the d falls under. So let's use the second query on the points 1 comma m, and the third query. So the key idea behind the second query is that you use the second query to find out either the column or the row. And let's say you find out from the second query that the column is something and the row is something. So let's say you fix either the column or the row, fix either r or c using the second query. And once you fix either r or c using the second query, you can essentially use the third query. So let's say you fix the third query. Let's say you fix r, which means you can just call query of r comma 1 to get this gives you c. This gives you c. If you have fixed r, you can get c, and if you have fixed c, you can get r. So you have to use either one of these two. Use either one of these two in the third query, and use the second query to figure out which third query to call, and use the first query to figure out which of the two cases the second query falls under. So the general outline is to split it up case wise. You start off with query 1 comma 1. You use the first query to split it up into two sections, into two cases. Case 1, r is less than c. Case 2, r is greater than or equal to c. Based on the two cases, you figure out which case it is by calling query of 1 comma n. You use this value of query 1 comma n to figure out whether r gets fixed or c gets fixed. So this is the first query, this is the second query, and you use this query to find out either r or c. So you'll notice that in case 1, since r is less than c, we can fix c. So over here, fix c is uniquely determined after the second query, and over here r is uniquely determined after the second query. So the second query is essentially to check which case it falls under, and depending on which case it falls under, you know which value is fixed. Either c is fixed or r is fixed. And once c gets fixed or r gets fixed, we can do query of r comma 1, I mean 1 comma c to get the value of r. So r will be equal to query of 1 comma c plus 1, and over here c will be equal to query of r comma 1 plus 1. Now that we know the general outline of how we are going to approach splitting the solution into three queries, let's figure out the two cases for the first two queries before we move on to the code. So we can find out whether it's case 1 or case 2 by setting c equal to query of 1 comma 1 plus 1. So let's call these three numbers d1, d2 and d3. So we know that if the first case is true, we can simply check that by setting c equal to d1 plus 1. So if c is equal to d1 plus 1, and if 1 is less than or equal to c is less than or equal to m, and we know that there are two possibilities based on the second values, based on the second query. So based on the second query, we know that the answer to the second query is maximum of r minus 1 comma m minus c. So we know that d2 is equal to this, which we get from the second query. Clearly, if if 1 is less than or equal to c is less than or equal to m, and this value of d2 and d2 is, if this should be greater than or equal to m minus c, only then the first case is true. So this means that the first case is satisfied because both the queries give the correct value of c, and otherwise we go to the second case. Now so in the second case we just set r equal to d1 plus 1, and then we do the same two queries. Then we just use two more queries to find c and to print the answer. Let's analyze the first case first, and then I'll show you the queries, the exact pseudocode for the second case. So when the first case condition is met, that c lies between 1 and m, and the value of d2 is greater than or equal to m minus c, where we get c from here. We know that r is equal to, so we know that either, so if d2 is equal to m minus c, then we know that r is just query of 1 comma c plus 1. Otherwise we know that d2 is greater than m minus c, so d2 is greater than m minus c, so this means that r is equal to this query, so r is equal to d2 plus 1, because because d2 is the maximum of these two, and since d2 is greater than this, we know that d2 has to be equal to this, so r is d2 plus 1. And now there's a key border case which comes under here. So if you just print r and c, so if you consider, if you are looking at the first case, and if you do this code so far, and if you just print r and c, you will actually get a wrong answer, because over here it's fine to print r comma c, but over here if you print r and c, you can get an error, because r may not be less than or equal to n, or basically the maximum of r minus 1 comma c minus 1 may not, m minus c may not be equal to m minus c. I mean, it may not be equal to d2, and the way to fix that is by checking if the maximum, if this maximum is not equal to d2, then we know that r and c have to be swapped. So it's actually going to be, so if the maximum is not equal to d2, or if c is, or if r is not less than n, so if r is greater than n, then so it's actually going to be the second case, not the first case, Obviously we ensured that we have already ensured by setting r equal to d2 plus 1 that the maximum of d2 plus 1 minus 1 and m minus c is equal to d2. So this condition will be met. This condition may not be met. So if r is greater than n, then we need to swap the values of r and c. So we need to set r equal to d1 plus 1, and we need to determine c using the second query. So we need to determine c using the second query. C is query of 1, I mean this is the third query. C is query of r comma 1 plus 1, and now we can print the values of. So after this little block of code which gets executed, we can print the values of r comma c, and this you need to write all of these cases for the first case. So all these sub cases belong to the first case, in which the value of c is equal to d1 plus 1. However, if any of these conditions are not met, then we know that the value of r is d1 plus 1, and over here it's relatively straightforward. We just query r comma 1 plus 1 and we print the values of r and c. So if you didn't fully get these three queries, you can pause. I'll show you the code and explain it again, or you can try to find a simpler solution in which you use lesser number of cases, but the basic underlying logic remains the same. And now I'll show you the code. So in the code, I have this query method which outputs, so this outputs r and c and returns the query and returns the input from the query. And I use this in every point of the code. So for each test case, I've taken the number of rows and the number of columns, and using the first two queries, I find either r or c. In the first case, I find the value of c. So if c is less than or equal to m and d2 is greater than or equal to m minus c, this means that case 1 is satisfied and we have found the value of c. So over here, if d2 is m minus c, we find the value of r and we print this value. Otherwise, if we have d2 greater than m minus c, d2 is greater than m minus c, so this implies that r is equal to d2 plus 1, and that's why we find the value of r. And using this value of r, we can find the value of c. So determine c using r, and note that if some condition from the first two queries is not met, then we swap r and c, and for safety reasons we can use one more query to find the value of c using r. Now if case 1 is incorrect, we know that r is equal to d1 plus 1. That's why we find the value of c using query of r comma 1 plus 1, and we print r comma c. And you can verify that this code does get accepted. So I hope you like this problem and my solution. If you have any doubts on any part of the solution, do leave them in the comments down below. And if you like this video, don't forget to give it a thumbs up. Thank you.